Hello everybody, my name's Simon. I'm a trustee at Rivermole Riverwatch and I'm going to be using this video to tell you about the November test results on the Rivermole as conducted by our Rivermole Riverwatch citizen scientists who test over 30 sites on the river through each month, and then the results come in and we present them and analyse them to see how the river's doing. This is a map showing the catchment along with triangles which show sewage works. You can see the layout, the relief of the river is you've got highland towards the south and towards the west here, the shoulders of Leith Hill and Worth Forest down in the south, and indeed the North Downs, the Chalk Downs here. They all kind of surround this clay basin into which the rivers flow, and then the river cuts through the Mole Gap here, the Chalk Hills, and then onto London's Clay Plain, and then out towards Esher to join the River Thames at Hampton Court. So that's the general outline of the river. I'll just switch myself off. So there we go. This November was characterised by a flood in November the 27th. This is Salford Stream, courtesy of somebody from Facebook. Thank you very much for allowing me to use this photo. This rose very quickly on the 27th after overnight rain of about 34 millimetres, and shows how flashy our rivers are, excuse me, to rain. They rise very, very quickly. Moving on back to the phosphate testing we've done. This is our longest running test, and we have this pattern time and again each month, which is lower phosphate towards the low order streams, the first order streams with very few tributaries. They're the ones to the south of Crawley, especially Bewbush Brook, Ivehill Brook, Upper Mole. These all have reasonably good water quality as measured by phosphate, and indeed several streams saw a distinct improvement, especially those without sewage works. Gadbrook, Pitbrook, Burstow, they all had quite an improvement in November, as we would expect with more dilution from more rain. However, some saw a decline. Red Hill Brook in particular had even higher phosphate than in September, and downstream of that, Salford's Brook was also poor. And in fact, much of the main channel all the way downstream from Dorking north through to the Thames was all poor water quality. Interestingly, streams next door to each other can have drastically different scores despite draining what you would imagine as similar landscapes, similar land uses. The obvious example is Lye Brook, very high scoring phosphate, which is always poor or bad, one of the worst streams in the catchment for pollution. And then next door to it is Deanoak Brook and Gadbrook. Both of these are considerably better than Lye Brook. Lye Brook has, of course, Homeward Sewage Works, this yellow triangle upstream. So that's the phosphate stats in terms of a map. Trends show what is now again a familiar pattern, which is generally low concentration of phosphate in winter with higher river levels. The blue here is river levels as measured at Leatherhead. And then you've got this much higher concentration of phosphate in summer. Particularly in July this year, it hit very high levels. This is an average for the whole catchment, by the way. And it shows very high levels of phosphate concentration in July. This is when most aquatic damage is done from high pollution levels, whereas in winter you might have more phosphate load being carried by more discharge, but it's generally less concentrated. And as we are told, the solution to pollution is dilution. So to some extent that's proven by this diagram. It's helpful to know it's not just aquatic ecosystems that suffer damage. This is courtesy of somebody from outside Hawley Sewage Works. The sewage works in November during that rain overflowed in the opposite direction to what we expected, and in fact it flooded people's garages and houses, creating a lake of sewage. It was tested by one of our fellow testers down there, Rivermole Riverwatch tester, and found to be most certainly sewage in origin. So very dangerous and disheartening, terrible flooding down there, which we're following up with Thames Water from a number of directions. This shows the spike in July for the Upper Mole, a selection of Upper Mole test sites, and it really shows that enormous spike in July. Fortunately, August was a tad wetter when we tested, at least, and that showed a dramatic drop. And that's kind of continued through to November, although flattened out somewhat. November was dry at the beginning, if you remember, but has subsequently got wetter. So we're looking at fairly typical results, which are very similar to last autumn, in fact. This is what good streams should look like, and these are streams with few tributaries. They don't have any sewage works, and generally speaking, it seems to be reasonably clear they don't have any or significant point sources of pollution. Nevertheless, 0.5 ppm of phosphate is still poor. So this line right down here, above which anything which exceeds this is judged as being poor water quality. So even some of these best performing tributaries do spike above occasionally into poor category. This, I suppose, is what the mole should look like if we were treating it properly. And even then, it's not entirely free from problems. This is where we're at in terms of the difference between streams without sewage treatment works and those with sewage treatment works. And you can see there's an enormous consistent difference between the two. We've got streams with sewage treatment works spiking up towards 2, this is average by the way, towards 2 parts per million in the summer. Many would exceed that into bad levels, which is over 2.5. There is a decline in winter with more water in the river, as I've said, but look at where we are with streams without sewage treatment works. These are averages, generally much lower, but even there we still have this spike above 0.5, which is into the poor category. So really what we're looking at here for the catchment as a whole is sewage treatment works contribute probably 2/3 of the pollution to our streams, but there is still, even if you took them all away, if you took all the sewage treatment works away, you'd still land up with rivers that are sometimes poor. And where do we think the pollution for that's coming from? Well, it must be everything else. So agriculture and misconnections, that's misconnections from people's homes, road runoff and so on. Here's the trend downstream. So now we're looking from left to right. Left is upstream, right is downstream. There's a pattern which is repeated each time, but it's not like an obvious pattern. So here we've got a number of tributaries with very high phosphate levels. We've already talked about Lye Brook and Redhill Brook and Burstow. These all have sewage treatment works, but then there are some without sewage treatment works which consistently score high. Hookwood Common Brook and Spencerskill must have some sort of runoff from agriculture or something like that, which is contaminating these streams. And then further downstream, we have the Gatwick Stream Hawley here through to Westvale. And then after that is the main River Mole channel, moving downstream towards Lower Mole. And there we have consistently high levels of phosphate, all of which are rated as poor on average. Overall, 80% of our streams are moderate, poor or bad, which is unacceptable from the Water Framework Directive point of view. Nitrate then, moving on to nitrate levels in November. Again, these are kind of reflective of phosphate. We have hotspots of nitrate pollution in certain streams, and particularly this time, real standout bad performer is Earlswood Brook, downstream of Earlswood or Reigate sewage treatment works, and then at Sidlow as well, which if you look at the magnified version of this map, you can see how Earlswood Brook joins Sidlow, joins the main River Mole just upstream of Sidlow Bridge. So we could be looking at something translated downstream there. Upstream in the Gatwick Stream records very low nitrate this month, which is good. There has, however, been a widespread increase in nitrate across many first-order streams. Although it doesn't look much, many of these have seen quite a considerable increase in nitrate this month. Further downstream, you've got this increase through the Mole Gap, which is consistent each month. And the place you don't want it really, because that's chalk and the water can obviously drain away into the chalk aquifer and contaminate what is 80% of our water supply in this area. Further downstream, the nitrate is maintained all the way to the Thames at a bad level. Here we've got the downstream nitrate levels for each individual test site as you move downstream, and you can really see here these spikes at Burstow Lake Lane and Earlswood Brook, Lye Brook, and then this high level going through the Mole Gap in particular. There is a slight drop off towards the Molesey, but there are high levels, many months. There are high levels through that vulnerable area. The distinction between watercourses with and without sewage treatment works are even more dramatic with nitrate. So you've got streams with sewage treatment works have very much higher nitrate than those without. And that's borne out by this example from Dorking. So you can see consistently here, although we haven't been testing for quite so long, since May at least, we've got consistently higher levels of nitrate downstream at the stepping stones. Ammonia scores are more kind of polarized. They're either quite low or ridiculously high, but we do have some consistency, like at Wallace Brook. That's consistently the highest scoring ammonia stream in the catchment. We've got various possibilities, reasons why. We need to drill down a bit more to be certain, but it looks like some sort of runoff from farm activity, particularly from horses and so on. Sidlow Bridge was quite high this time, not entirely sure why. So and generally ammonia levels were lower in the lower mole than the upper mole. So there's something to think about. There is a general decline of ammonia concentration downstream, maybe due to dilution. One interesting thing is that it's completely the reverse. Streams with sewage treatment works have lower ammonia than those without, and this is consistent, especially in summer. We're told from our Thames Water, ex-Thames Water testers, of which we have several, which is very useful. They tell us that sewage treatment works with ammonia strippers work better in warm weather. So you're going to get a lowering of ammonia downstream of sewage treatment works because they're actually quite effective at taking it out. So that's interesting. Overall then, the scores are slightly lower in terms of concentration of the main ones that we test. That's phosphate, nitrate and ammonia this month, just a nudge lower than October, as you would expect. So that's good news in some ways, but it's only due to dilution to some. The River Mole catchment certainly has its fair share of thousands of hours of sewage discharges. That's untreated sewage discharges, which are called storm overflows because they should only occur during heavy rain. And this has gone up in 2024. It's exceeded 2023 already, and we've only got to November. So looks like it's going to be quite a considerable increase. Obviously, there's some correlation with rainfall. If it rains a lot, you'll get more sewage discharge, but it's not entirely fixed. It's not completely solid correlation, and it should in any case be going down regardless of rainfall. And some of the smaller pumping stations, while some of the bigger sewage treatment works are actually sort of getting somewhat to grips with the duration of storm overflows, it's these smaller pumping stations which we've noticed are really increasing, and many of them because of increased housing. So Pease Pottage down here has increased year on year and has more housing going in. Hundreds more homes have been built, and this is going to generate more sewage, which it has to pump, and it will overflow if it can't cope. Same with Irons Bottom. That's actually a small sewage treatment works, but it's been discharging an awful lot. Look at this, nearly 840 hours this year, much more than last year and much more than the year before. Charlwood Pumping Station also has its moments and has had some dry spills as well. Stonebridge and Brockham has 3 at least, plus a very dodgy manhole cover at Castle Fields, which we're looking at, and is very well monitored by local people there. The Stonebridge storm sewer overflow, which is very visible to certain residents, the data here is a bit wobbly because at least half the time through the early years it was offline, so we can't really tell where we're at with that one. Here are the main sewage treatment works, and you can see lots of ups and downs, but generally a lot of them, if you look, have come down maybe since high points in 2020, which is quite a bad year, and are actually ticking up again. So Homewood, especially Esher, Burstow, Earlswood, these are all kind of going up where they should be going down. So there we go. Let's finish with a lovely picture of the mole from one of our testers down in the lower mole. I hope you've enjoyed this very quick whiz through our data from November. And this is an experiment, so we'll see how it turns out. And if you can support Rivermole Riverwatch, please do. Our website has a Just Giving button somewhere on it, so please click that and try to support us. We have so much going on. If the video seems appealing, I'll try and do more of these. It's a perhaps arguably a quicker way of getting information out there. So thanks so much for listening this far, and yeah, see you again.